Hi there. So in this video we're going to clear out that central bore and we're going to take a look at the castellation features in the centre of the piece as well. So first things first, we shall take a look at the best approach for clearing out that bore. Now ENCY has got a lot of hole machining options made available to it. Obviously on a cursory level you think, oh, all it's doing is it's making a hole. There's not a lot to think about there, but you'll see. So I'm going to add a new operation, and we've got a whole subsection, pardon the pun, dedicated exclusively to holes. And we're going to click on hole machining and then create. Now, as we can see, it's decided that obviously the best tool for hole machining is this honking great 12mm drill, which is not actually part of our tool selection. So we're going to redefine that. So first things first, we're going to go down to the tool option, and I'm going to do something a little unconventional. I am going to use the 20mm end mill for our large bore. So I'm going to select the tool for the operation. We're going to go back to strategy now, and we're going to take a look at the drilling type, because at the moment it's just simple plunge drilling, which is not really appropriate for an end mill, not unless you've got a lot of spare end mills kicking about. I'm going to click on the drop down menu here, and we're going to go with hole pocketing. So this will give us what we need to cleanly remove material from the center of that bore without damaging our tooling, without causing a huge amount of noise and mess and other horrible stuff. So at the moment, all of these settings look pretty sensible. We've got a 10-degree ramp angle for our helical step. The spiral step is 50% of the diameter of the tool. That's pretty good. Depth of cut is 2mm or 10% of the diameter of the tool. Again, pretty good. So we're going to have a quick look at job assignment now, so we can tell it exactly which hole it is we want it to work on. So again, I'm going to grab the bottom edge of this bore and I'm going to click on center. Now, the first thing that happens is the center point of the tool drops straight into the center of that indicated circle. This is not really ideal because it means that it's automatically assuming that it's got direct access to that point in the material, which it doesn't right now. So we need to highlight this and then click on properties. And this will allow us to define the top and the bottom levels of this bore. So at the moment, the Zmax is actually -2, and the Zmin, don't forget again, the bottom is going to be 2mm below this point as well. So the Zmin is going to be -24. So we're now going to click on OK, and it should allow us to generate a toolpath based on these parameters. So this all looks correct. So let's click on generate toolpath now, and we can see we've got this very nice helical boring path that's just turned up. So on the face of it, I'd say that looks pretty good, but again, you know the drill, pardon the pun. Let's take a look at the simulation, shall we? So I'm going to let this run fairly fast because obviously it's doing a 10mm step down, sorry, a 2mm step down on nearly 22mm, well, yes, 22mm of material. So that's going to take a short while, so I'm going to leave it running at this rate. But as we can see, it's doing a nice and predictable angled helical path on each pass. I don't think it's going to be stressing anything unduly there. And of course it's clearing out the bore to final diameter as well, which pretty much meets our needs perfectly. So we'll give it a second, and there we go. We can see it's cleared out the bore entirely. I think that's pretty good. So that means that we can now focus on the next part. So the next part now, if we go back to the machining tab, we are going to finally change tools. We're going to be taking out these little castellated slots, and we're going to do so with the 6mm end mill, and we're going to do so using a 2D contouring path. So if we go back to add operation now, and under 2D we go for 2D contouring and we click create. We need, conveniently we're in the job assignment tab at the moment. That's where we need to be at this point. So we need to grab the various features that we're going to use to define this. And under the job assignment tab, we've got a few different options and tools available to us. The only ones that we're really interested in right now are curve, top level and bottom level. So that's what we're going to work with right now. So you need to make sure that you've got your edges selection turned on in your selection menu. And we are going to grab this edge and this edge. Okay, and we're going to click on curve. Now you can see at the moment it's got a single band there and we've got the conical tool selected for some reason. We're going to change that now before it starts to get the wrong idea. So we're going to go down to the tool tab and we're going to click on the select tool button and we're going to click on the 6mm cylindrical mill button and then select tool for this operation. Now this has changed over to 2 passes. This translucent green band here currently describes the expected depth of the cuts. Obviously this is going all the way down to the bottom of the material, which is not really relevant to our needs. So we're going to go back to job assignment and we're going to be using the top and bottom level selections to try to minimize the amount of damage that can do. So to start with, we're going to click on this upper face here and we're going to click on top level. And then we're going to click on the bottom of this castellation and click on bottom level. And you can see how that has now suddenly just been completely trimmed to stop there. That's pretty much what we're after. The last change that I would make to this is I would quite like to see a lead in and a lead out on these paths, because otherwise it's just going to try and plunge into the material and then cut straight in, which puts a certain amount of unfair loading on the tool. So to do so, we need to go down to the links menu here and we're going to scroll down a little bit and you can see where it says leads, engage and retract. That's what we're going to take a look at. So I'm going to click on engage where it says off and there's a drop down menu here and I want to do by arc. So the default information that it sets is actually pretty good. You've got just over a 7mm radius of a 90-degree angle of an arc there. And you can see how that's been applied to both ends of both paths. That looks pretty good to me. The last thing that we're going to define is the step down on these paths. So I'm going to click on strategy again, and you can see that the depth of cut is set to 100% of the diameter. We're going to mix this up slightly now, so we're actually going to click on the bottom right corner of this here, and we're going to click on by count, because I don't really want to calculate what 2.5 millimeters out of 6 millimeters is as a percentage. Sounds a bit fussy because it's only cutting 5 millimeters total depth. So we're going to go with count and we're going to put in 2 there and we're going to press return. And we're now going to let it generate. So we're going to let ENCY do the maths for us on that and work out what 2.5 is relative to 6, because I certainly can't be bothered at this stage. And it's come up with a guideline for the path and what the 2 path heights are going to be. Again, this is looking pretty good so far. So we're going to simulate, because that's what we do at this point. So we go to the simulation tab, we're going to zoom out slightly. Going to run the speed down because it's only doing a couple of contour paths, there's nothing drastic going on there. And we're going to click on run. So bring it up slightly, move in, wait for the tool to come down and into play. And you can see how it's doing quite a nicely controlled curved path there, leading both in and out in 2 steps. I would say that's exactly what we asked for, and it looks like it's doing a very nice job of it too. So that means that we've now got the first slot of our castellations sorted out, and I'm quite happy with that. However, how are we going to do the other 5? So we've got a couple of options here. We can either do each of them manually, which is not really optimal, Or we can do a slightly more complicated path and grab each and every one of these curve edges and set it all up in a single go, which can be done, but again, it's not super optimal. Or we can be a bit fancy at this point and we can do the whole thing as a radial array. Now, I imagine most of you will be pretty comfortable with the idea of what a radial array is. If, however, it's a term you've never encountered before, an array is just a way of describing repetitions of an object or an action or some kind of token value. And typically you get linear arrays, you get rectilinear arrays, so that's an array in X and then an array in X and Y, as if it were a graph. Radial arrays allow you to do an array in the format of a circle. And ENCY, of course, has a tool for this. So we're going to go back to the Add Operation menu, and we're going to go to Structure, and we're going to go to Multiply Group. And I'm going to click on Create. So we're now going to go into the settings of the Multiply Group here. And you can see we've got a different set of inspector tabs here. This is due to it being a setup stage as opposed to an actual operation by itself. So the first thing that we need to do is we need to define that we're going to use the multiply scheme instead of multiply toolpath by axis. So I click where it says none, and there's a drop down menu there. So we've got the different array options here. I would like a round array, and the instance count is going to be 6 because we need to cut 6 slots. The angle step is going to be 60 because it's going to be a full circle, and we are going to define this as being from this center point. Now, if you remember correctly, the XY value of this was at -75, -50, because it was originally predicated off this center point. So we now need to tell it that XC, which is X center, is 75 and Y center is 50. So that's now calculated around that center point. So we are now going to drag our 2D contouring path into that multiply group. So it's a nested group, okay? And we're now going to click on Generate Toolpath of the current operation. And we can see it's come up a little bit goofy there because it hasn't preserved that G54 data properly. So we're going to click on Return There Again and Return There Again. And we're now going to regenerate the path. Okay, so I had to reset the current operation and regenerate the path there. Sometimes it will try to retain old values. So if you're at all unsure or it's doing something you're not entirely expecting, reset and regenerate. 9 times out of 10 that will get you out of a bind. Okay, and in this instance it's done it perfectly. So it's now gone and set up 6 instances of this exact path that we'd asked it to. So we can now double check this is correct by running the simulation. So if I click up on the simulation tab now, and we are going to reset the simulation, and we are now going to click on multiply group here and then simulate up to current operation. Yep, sorry, we needed to do that on 2D contouring, not on multiply group. And we are now going to click on run, and we're going to let it do its thing. So we'll just speed it up a little bit so we're not stuck here for absolutely ages, because as compelling as simulations are, they can be a little time consuming. And as we can see, it's already wrapping our one toolpath around that central rotary axis, and it's doing it 6 times, which is pretty much perfect for our requirements. So as you can see, the setup of radial array tools is very, very simple in ENCY. There's no mental heavy lifting involved. It really is just a case of there's the center of our circle, that's how many times, that's how far you need to step each time. It's a wonderful tool and a real time saver in that regard. So we've now cleaned up the center bore and the castellations on this part, In the next video, we're going to take a look at doing some of these curved slots as well. So I shall see you in the next video.